Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 22, the 22nd episode of Code Katas. Thank you so much for tuning in. Let's say hello to all the wonderful people in the chat. Hello YKK, welcome. Tipsy has to go study for an exam, good luck with that. And Joe, welcome to the stream. Hello Andrew Lane, welcome back. And Alicia, good evening. Hey Isaac, it's going well. Alicia says they just took their exams. I'm pretty sure they failed. I hope not. Cool. So if you are new to this show, I have a GitHub repo. It's github.com/codinggarden/code-katas. You can see all of my solutions from past episodes, and you can see links to the ones that I plan to do tonight. We're just getting started, but this is my break timer, so let's take a quick stretch. Ooh. Hello, Alka. Welcome to the stream. And gaming, but not really. It has been a while for both of us. Welcome to the stream. And hello, Tony. Hello, Vias. Welcome. Chad says, let's crack some code katas. And Jesus, hello. Joshua, good evening once again. Josh was hanging out last night with us. And hello, David. Dope hat. Appreciate it. Cool. So the katas that I have picked out for tonight, the first one is a 7Q. It is Regex validate pin code. And it's loading very slowly. I'll just open all these links because... Okay, here we go. So the first one is a 7Q Regex validate pin code. Next one is a 6Q. Delete occurrences of an element if it occurs more than n times. Next is a 5Q. We're going to be creating a vector class that implements add, subtract, dot, norm, etc. And the last one is a 5Q, and it is a tic-tac-toe checker. I didn't choose any 4Qs tonight. Those are actually pretty hard. I did stream for like 3 hours last night, so probably only going to stream for like an hour and a half tonight. So we've got some picked out. It's going to be fun. And hello, Rabbitworks, welcome back. Hello, Puggles, welcome back. Hello, Rolando. Hello from Panama, they say. It's great. Yeah, and Gaming But Not Really says Regex is always fun. It is. If you look back at some of the past code katas, you can see me struggle with Regex. And so this one's pretty easy, and we can just explore some different ways of solving it with Regex. So without further ado, let's get right into it. So I like to pull these down locally. We create a new file, call it that.js. We'll bring in our function, and we'll bring in our test cases. Here's what we'll do. These should all fail. And I'm just going to convert them all to console logs. A little bit of that. Pretty much done. One of those. Cool. Okay, so I'm going to use a tool called Quokka. And so this runs the code inside of my editor. And we can see right now our function returns undefined. And we can see all the cases where it should return false. So those are all things that should break. And then we can copy some ones that should return true for these. There we go. Cool. So let's read the description. ATM machines allow 4 or 6-digit PIN codes, and PIN codes cannot contain anything but exactly 4 digits or exactly 6 digits. This is a great case for a regular expression. Essentially, we can make sure that the string only contains 4 digits or only contains 6 digits. Anything else, it is not valid. So if it is valid, we're going to return true, and if it's not valid, we return false. Cool. And before I do get started, let's catch up a little bit. Some more people joined in. Hello, Dan Levy. Welcome to the stream. Danielle, welcome. Joshua says, regex makes my eyes spin in opposite directions. I think for this one, because it's an easier one, I'm going to try to break it down. I'll look up resources on like regex and what do the different parts and pieces mean, and we'll construct one by just reading about it. Cool. Oh yeah, and Andrew Lane mentions regex101.com. I'll probably check that out. And Andreas, hello, welcome to the stream. It has been a while. Ahoy, Bob, welcome. Josh says the comma on line 12 stands out in my neat brain. Where is it? There it is. Let's get rid of it. This is interesting, though, because in the more recent version of JavaScript, you can actually have trailing commas in your function invocations, which is interesting. But there you go. That one was for you, Josh. Okay. So what do we need to do? So we have the pin. Check if only 4 digits. If not, check if only 6 digits. Easy enough, that's our pseudocode, but let's actually look up some regular expressions. Dan has a solution in the chat, Alka has a solution in the chat, but we're gonna figure this out. I'm gonna try regex101.com. Is that what Andrew Lane suggested? An online regex tester. Let's just look at I was going to look for like a regex cheat sheet, but really what we want is we want a regular expression that matches a digit. So let's just search the web for that. Regex to match digit. This was DuckDuckGo. Let's try Google. Regular expression tutorial. Escape sequences, occurrence indicators, numbers 0 through 9, okay, or /d. So in a regular expression, if you want to match a digit, that is a number 0 through 9, you can use this notation. And this is essentially a group. It captures all numbers 0 through 9. And this says 1 or more. The plus sign means 1 or more. And then the other way to do it is /d plus. So that's 1 or more digit. So that's a good place to start. So let's create a variable. We'll say like is valid. And we'll do pin.match. So match is a built-in function on strings that I believe it is string match. Yeah. And you can pass in a regular expression. So you can say some string.match, put a regular expression there, and if it matches, it will return what matched, and if it doesn't match, it will return null. So let's try it out. So let's just try it on this very first example. We'll say match, and in JavaScript, when you're using regular expressions, you use forward slashes. So your regex is going to go inside of the forward slash. And let's say we just want to check for 1 digit. So we're just going to do /d plus. And then let's log is valid. And in this case, we actually get back some stuffs. So right now we're passing in 1 as pin. We run, is there 1 or more digit on this pin? And right now we get back some result. But let's say we were to pass in like the letter A. When we try to match that against a single digit, we get back null. So this will match 1 digit. Cool. Now, what if we do 2 digits? Now, technically, it matches because this is 1 or more digit. We could explicitly match a digit and then match another digit. Sure. But let's say we wanted to check for it to only have 1 specific digit. How would we do that? Because right now it's passing. Even though there are 2 digits in here, this is just matching the first thing it finds and then it quits. We could get more specific and say it must begin with 1 digit and end with 1 digit. So let's see if there's anything on begins with. Yeah, so I'm not seeing it exactly, but it's this character here. So if you use the hat, that means must begin with. So we'll say must begin with a digit. And for instance, if we pass in like something starting with the letter A, it breaks because it didn't begin with a digit. Cool. The other thing is we might want to say, does it end with? So begin, match 1 digit, and then end. So there's a character that will match ends with. I'm not seeing it on here either, but it is the $sign. So a $sign means the end of the string. So if we write a regular expression that is $d $sign, that means we're only going to match a string that contains a single digit, right? So when we pass in 11, technically that fails because it's 2 digits. But if we give it just 1 digit, it will pass. So you can kind of see where I'm heading with this. Like, we could get really verbose with it and say we want 4 digits. So 1, 2, 3, 4. And now it's only going to work on 4 digits. So if I test it on these things, so let's test it on the string 1, 2, 3, 4. Whoa, whoa, whoa. My mouse has gone crazy. This matches the string 1, 2, 3, 4 because it matches exactly 4 digits. That's great, right? And if we were to match it against 0, 0, 0, that works as well. If we were to match it against 1, 1, 1, that works as well. So we kind of have it, right? And then we could also check against 6 digits. And this will fail because right now we're checking for exactly 4 digits. So if we wanted to be really verbose about this, we could say is 4 digits is this one. And then we can make another one that says is 6 digits. And then we'll just throw in 2 more. And ultimately, we can say it's valid if is 4 digits or is 6 digits. And this should work. We can write a much better regular expression. We're going to look up some other syntax we can use, but this is one way of doing it. Let's take a quick stretch. I see all sorts of suggestions in the chat. And trust me, I will get to those things. But for someone that's new to regular expressions, like, you don't have to be super fancy with it. Like, you could do exactly what you're looking for, and technically that'll work. We can rewrite this with a single regular expression, which we'll do next. But let's catch up on the chat. Yeah, so I have like the very succinct answers from Alka and Dan. I'll definitely show those. And hello, Just Some Aussie. Welcome to the stream. Andrew's saying Regex 101 has a cheat sheet. Let's look at that site, because I was just going from memory because I have used Regex quite a bit. Let's look at regex101.com. Flavor, JavaScript, quick reference. Begin. Common tokens. Yeah. Okay, here we go. So start of a string, end of a string, we use that. Is digit in here somewhere? Yeah. Any digit, any non-digit is /d. Cool. Yeah, so that's some nice stuff there. Okay, so this is one valid solution, and if I try it against everything, it should technically work for all cases. So, and really, I want to turn this into a Boolean, because right now it's returning null instead of false. So, Alka did mention test, so this is another function built into a string. Let's look at that on MDN, because that might return true or false. Or it would be regex.test. Let's see what this one does. Yeah, so you flip it. So instead of saying string match regex, you can say regex.test and pass in the string. And that's probably what I want to do, because you'll see right now it's not returning a Boolean, it's returning like the actual match. So let's flip it. Let's say this thing dot test the pin. And then same thing, this thing dot test pin. Cool. And so test works in a very similar way, but instead of giving you back what actually matched in the string, it just returns true or false whether or not that thing matched. And this seems to work for all cases, so that's great. Cool. So let's make it a little bit shorter and try to do it all in one go. So I want to be able to just return some regular expression like this and instantly get the answer. So if we do look at our cheat sheet, is there, if I search for or, meta sequences, common tokens? It's really hard to find the things I want. Like, I know what it is, but I want to find it so that if someone out there in the world were trying it themselves, they could find it too. There we go. Match either. Okay, so the single pipe is a way of matching either A or B. So we can actually put both of these into a single regular expression. So let's say match this or match this. So what this says is match anything that is 4 digits or match anything that is 6 digits. And this works for all cases, so that's great. We can make this even shorter. And look at some of the solutions that got sent earlier. Yeah. And one thing you'll notice I'm doing is I have begins with and ends with, or begins with and ends with. We could actually wrap this thing in parentheses and do it all in one go. So if I get rid of this and then wrap this whole thing in parentheses, this will work the same way. So it says begins with, and then either 4 digits or 6 digits, and then end of the string. And so this works in the same way. Very cool. Yes, so Alka just suggested that one. And essentially, instead of repeating ourselves here, we put the group we want in parentheses and then just have the begins with and ends with on both sides. Cool. And then another thing we can do is if we're repeating something in a regular expression, there's actually syntax to say a certain number of these things. Let's see if we can find it. Meta sequences, anchors. Yeah, 3 or more. So the curly braces with a number inside of it will give will match a specific number of that thing that you're matching against. So this syntax shows 3 or more, so 3 comma. But if we just do curly braces 4, that will match 4 digits. Or if we do right here curly brace 6, that will match 6 digits. So this is pretty much the exact same thing as this, but it's a little bit shorter because we have this shorthand that says match 4 digits or match 6 digits, and this works in the same way. Very cool. Oh, and Alka is mentioning we actually don't need parentheses around the regular expression. So you'll notice I'm wrapping this in parentheses and then doing .test. I think JavaScript actually allows you to just do that, which seems a little bit weird in terms of how syntax goes, but this actually ultimately it resolves to a regular expression, and then that itself has properties on it that you can call. So we can actually get rid of these parentheses too. Cool. Let's catch up and say hello to the peoples that have joined. Yeah, and so Alka suggested in the chat, essentially this one. In the chat, he also put a G right here. And this is a modifier and means globally search through the whole string. But in this case, we don't need it because we're explicitly looking at begins with and ends with. So we shouldn't need that modifier. Oh yeah, and Andreas, off topic, submitted a pull request to Meower. I will definitely take a look at that soon because I think it's broken if people try to pull it down. So I'll take a look at that. Yeah, and Gaming would not really just ask, isn't there something called isNan in JavaScript to check if a string is a number? Yes. We could use it potentially in this case. I think for this solution they wanted us to go full regular expression, but we could like check to see if the pin is NaN to begin with, meaning it contains things that are not digits. It would fail, but yeah. Multiple people are telling me I didn't need parentheses around the regex. Cool. Yeah, and Christopher Fitzgerald suggested that we do this. So you could do... However, this will not work because this matches between 4 and 6 digits. So this would actually return true for 5 digits, which is why we have to break it out into 2 separate ones. Yeah, Alka and Dan are leading the chat with suggestions and solutions. Yeah, and Alka is saying, yes, we are as succinct as it gets. So multiple ways to write it, multi-line with an or, and then ultimately that's pretty much as succinct as you can get with regular expressions. Cool. And hello, James Ross, welcome to the stream. And Daniel Garden, welcome back. And hello, Sean, welcome back. He says, yay, 2 nights in a row. Yeah, I streamed for 3 hours last night. It was super fun, though. I had a ton of fun writing all that code. Cool. Why is this underlined? Oh, it's, yeah, that's fine. I just have the function defined multiple times. Cool, so let's put this on Code Wars and see what happens. Sample tests. Pass. Let's attempt. Yay! I got 8 points. Cool. Cool, but for all you newbies out there, like, regular expressions look super weird, but just approach it like one thing at a time. Like, I want to match this thing, how can I just match that? And then eventually you can learn the tricks and the syntax to make it a little bit shorter, a little bit more succinct, but there's nothing wrong with being verbose. Yeah. Oh, and Andrew Lane asked the question, would it work if pin is a number and not a string? No, it would not, because I believe test requires a string to be passed into it. So if we passed a number into this, we might get some weird error. Yeah. We could try it. Let's see what happens. So if we try to run like that, oh, it actually works. Huh. Yeah, it works. I did not know that. So I'm guessing under the hood, potentially test coerces the number into a string, but apparently you can pass a number in here and that will work. Good to know. Josh is asking, out of interest, do I use the live stream comment viewer that I coded a while back or just YouTube? Right now, I'm just using YouTube live chat. The main reason is that chat viewer that I coded a while back, I haven't updated the code to dynamically get the latest live stream ID. So like anytime I wanted to use it, I had to push the live stream ID of the stream that's happening. I could definitely update it though. I could basically make it so that I log in with Google. It has access to all of the stream IDs for my account. I could choose a stream ID and then see the comment feed or the chat feed. I just haven't had the chance to update it. Cool. And hello, Mohammed. Welcome to the stream. Yeah, they're in Gaming But Not Really is mentioning there's just so much regular expressions. There really is, but like I said, take it one step at a time. Learn a little bit here and there. Cool. That one submitted. Let's see how other people did it. This is pretty much the solution that we came up with. This sort of short circuits it, so it just... Oh, so they're combining like code with regular expressions, because basically they just check to make sure the length is either 4 or 6 before even passing it into the the regular expression. So if it's the right length and it only has numbers, then it returns true. Yeah, same thing here. But here they're not using a regular expression, so this is interesting. So because we're getting a string, we're going to make sure that it's either length 4 or length 6. Then we're going to turn it into a number. And if you pass anything into parseInt that it like doesn't have digits in it, it's not going to be equal to itself. And they're using double equals here, which will coerce the string on the right-hand side to be a number. Very interesting. Cool. That was fun. Moving right along. Cool. Okay, so this next one, delete occurrences of an element if it occurs more than n times. The wording on this one is super wordy. So honestly, I think I'm just going to try and describe the problem to you myself. Okay, so let's bring it down locally. We have our tests. We'll start up Quokka. Let's see what we'll get. Okay, so the idea is you're going to get past an array, and you're also going to get past a number. So that number is the max number of occurrences of any other number in the array. So in this case, we get this array and we get the number 1. So the array that we return should only have any number occurring up to 1 time. So we start here. This is the first time we've seen 20, so we leave it. Let's take a quick stretch, quick break. And Mohammed says, thanks for the series. It's helpful. You are very welcome. Okay, so we have this array. Each number can only occur up to 1 time. So first time we see 20, we leave it. First time we see 37, we leave it. This is the second time we leave 20, so we're not going to include it. And then the first time we see 21. So ultimately, the array that we return only has numbers that occur 1 time, and they're in the correct order. For this case, we have an array, and we're given the number 3. And that means any number can only occur up to 3 times. So first time we see 1, it's good. Second time we see 1, it's good. First time we see 3, second time we see 3, first time we see 7, and then we see 2, 2, 2. That's the third occurrence. So any more occurrences of 2 would get removed. So ultimately, the array that we return only has 3 2s in it, not 4 2s. So this is going to be basically iterating over the array, keeping track of what we have seen, and returning a new array that only contains the number of given occurrences of the number that was passed in. Are you with me? Cool. Let's see if they have any other examples in here. Yeah, so let's also see this example. I'm almost there. just doing some formatting. Cool. Okay, so in this case, we're given an array with a bunch of 1s in it and the number 2. So ultimately, anything in this array can only occur up to 2 times. So the first time we see 1, it's good. The second time we see 1, it's good. Then every other one we see after that won't appear. And the thing that we return only has 2 1s inside of it. I think you get the idea, but let's try to like pseudocode how we will actually solve this. Yeah, so we definitely need to iterate over the array, but we also need to keep track of the counts of each number. So we'll say a place to keep track of the numbers and numbers we have seen, including count. So as we go over the array, we'll check to see, have I seen this number before? And if I have I seen it this many times? Okay. And if I haven't, we're going to keep it. So in that case, we'll need a place to store the result. And this will be an array. So we'll start off with an empty array, and then what I'm thinking is we'll iterate over this array, and as we come across each number, if the max count isn't reached, we'll push it into that array. So we will then iterate over the array. Does iterate have 2 T's? 1 T. Okay. If we have not seen the current number in times, then push into result array. Else, do nothing. We'll just ignore it. Meaning if we have seen it in times, we're just going to skip over it and we won't push it into the array. Awesome. At the end of it all, we will return the result array. Cool. The first way I solve this, I'm just going to use basic for loops, but then we could probably, I think I'll do it with a for each so you see how that works, but we could do this with a filter. We could probably do it with a reduce. Yeah, we could get really, really interesting with it. Cool. And hello, Brandon. Welcome to the stream. They say, I actually made it for a live stream today. Been enjoying the old ones for the past week or so. That's awesome. Thanks for watching. Yeah, and Gaming Good Not Really is saying, I think this can be solved with a frequency array. It's called a hash map in Java. In JavaScript, that's really just an object. Objects are key value pairs. They're essentially hash maps. If you're a JavaScript developer, and you haven't used other languages, you might not think of them like that. But coming from other languages, the JavaScript object basically behaves like that. Yeah, and Josh is saying, my brain always screams object when I see things like this. So for the place to keep track of numbers, I am going to use an object, and it actually will be pretty efficient because when we're looking up to see how many occurrences of a given number there are, that's an instant lookup. We just ask the object for the count, and we get it back instantly. So it won't take a lot of computation to do that. Okay, so let's turn this into code. So a place to keep track of the numbers we've seen, including their count. So I'm going to call this counts, and it is going to be an object. Ultimately, it's going to look like this. It'll have a number, and then like the number of times that we've seen it. We'll have a number, and then like the number of times that we've seen it. So as we iterate, we're going to be adding keys in here or updating their existing value. And that reminds me, I actually missed a bit of pseudocode. So push into the result array, increase count, and then repeat. Cool. So we have our counts. That's where we're going to store and keep track of things. We then need a result array. It's just going to be an empty array. And now we can iterate over the array that got passed in. So we'll have a for loop that goes from 0 to the length of the array. Let's just call this current number. That's going to be array at index I. And inside of the for loop, we're going to want to do this stuff. OK. If we have not seen the current number in times, so we need to do a check here. So we'll say if counts at current number. So what we could do is we could say if counts doesn't exist, so if current number doesn't exist in counts, that's great. We're going to add it because we haven't seen it yet. Or if it does exist in there, we want to make sure that counts at current number is less than in. So this little bit of code right here says, basically, we're looking into the object for a property that is the current number. And if we haven't seen that number yet, then that's great because I don't think in can be 0. If it were 0, then we would just return an empty array. But like if in is 1 and the current number is not in counts yet, then technically we haven't seen that number because it's not in there yet. So that's the case. But if we have seen it, we want to make sure that the count that is there is less than in the number that they passed in. So if this is the case, we'll say result.push current number, and then we will increase count. And so what we'll say, this is a thing you'll see often. We'll say counts at current number equals counts at current number or 0. So we're basically either setting it to itself or initializing it to 0, which then allows us to just increment the count on the next line. This is a shorthand, but basically what it allows us to do is if we have seen the number before, we're just going to leave it the way it is, then increment it. But if we haven't, we'll set it to 0 and then increment it to 1 because this is the first time that we've seen the number. Maybe you like it, maybe you don't, but this is actually really, really common when you're solving problems like this and when you're building up like an object of counts or something like that. Yeah. Hello, my ear. Welcome to the stream. Yeah, and Josh is asking, what if in is 0? If in is 0, then that means we need to return an empty array because that means no number can occur any number of times. When we run this through the tests on Code Wars, we'll see if they ever pass in as 0, and then we can account for that. But I don't think we will have to. Cool. And then that should do it. Lastly, we just return result. Cool. And I think we've done it. We can see this is our output and our expected output. This is our output and this is our expected output. Cool. So we have done it. But like I said, we can write this using probably do a reduce. We can probably do a filter. I think we'll gradually build up to that. And just for now, let's throw this into Code Wars and make sure it works. Oh no! Oh no! Did I just quit Chrome? I just quit Chrome. Okay. Sample test. Okay, so it works for the sample test. I think we're good. Yeah, and Andrew just came up with a shortcut. Actually, what is 0 plus plus? Would that work? Left-hand postfix operation. Yeah, I don't know if that would work, Andrew. We could try it in a second. But basically, he was trying to shorthand this piece of code right here. Okay, but let's write this with a for each, so we can kind of build up to a reduce, or build up to a filter. So let's remove all the stuffs. Cool. And we're just going to turn this thing into a for each. So I'm going to pull out the code that's in the for loop. We're going to say array.forEach. And we'll just call it current number because that's what we called it before. And inside of it, we'll do that. And this should work in exactly the same way. And it does. But now we can kind of see how for each compares to a for loop. So instead of having to specify your iterator, you give it a function that will get called on every number in the array, and we can do the same thing. Great. Okay. Let's now do we could do this with the filter. So let's do it with a filter. And the way a filter works is, so we'll say array.filter, and really we're just going to return this because that is going to be our result. And a filter returns true or false, so whether or not that number should appear in the resulting array. So in this case, we're no longer pushing into result. So if we haven't seen it and the number is less than our counts, we're going to increment counts and return true, meaning this number should appear in the resulting array. Else, we return false. In this case, it's just going to return undefined. So this will also work. Like we could explicitly return false here, meaning that that number won't appear in the result. And that should do exactly the same thing. And it does. Cool. Yeah, so basically, filter takes an array and returns a new array that only contains the items where the function you gave it returned true. So we're only returning true if we haven't seen it before, and then we're returning false. Well, not if we haven't seen it before. If we haven't seen up to the number of max occurrences, otherwise we return false and it won't show up in the array. So that's great. Yeah, people are chatting about... Oh, that would work. Alkyd Minson is just +1. But basically how we can shorten this. And really, I think what we can do is that +1. And that makes it a little bit shorter. And that still works. What I was saying to Andrew that probably wouldn't work is if we did that ++. Yeah, something weird happens. But in this case, we can just say, if it exists, we're going to take that number and add 1 to it. Otherwise, we're going to take 0 and add 1 to it, which gives you 1. Cool. All right, and now let's try to write this with a reduce. Okay. And the thing is, it's possible. Definitely possible, but what I'm going to try to do is inside of our reduce, potentially we include the counts as part of our accumulator. Don't know. Andrew Lane says they left a screenshot on Discord. Let's check it out in the live chat. Yeah, so the number that gets returned is 0. You can do ++ on a 0, but on a variable that contains a 0, but I don't think you can do ++ directly on a 0, which is ultimately what would happen here. Because we're not incrementing a variable, we're trying to increment just a number, which doesn't work. Earlier I accidentally closed my browser. Ross says, and hello Ross, says turn on warn before quitting in Chrome. I don't actually like it. I do have Chrome. I tell it to open all of my previous tabs, so I'm okay with that. Because actually, sometimes I just want to quit Chrome without it asking me if I want to quit it, you know? Cool. So let's write this with a reduce, and then we'll take a look at some of the solutions that people have posted in the chat. So here's what we're going to do. We're going to do a reduce here, and then now that we're doing a reduce, we are not going to use any outside variables, and we need an accumulator. What I'm thinking is our accumulator actually contains two things. It contains the counts, which is an object, and it also contains the result, which is an array. And now our reduction is happening on this object, and it's operating on this object. And then ultimately, the thing we will return from it is the result property. So we need to include our accumulator. What should we call this? Results? All? What's a good name for this thing? Count and result? Actually, we could just destructure it. I think that's what we'll do. So a cool thing in JavaScript is, so this parameter right here is our accumulator. So in a reduce, the second parameter is what is going to be the first thing that gets passed in as the accumulator. And then typically you return the accumulator at the end of your reduce, and then that's what gets passed in to the next call of the function. But what we can do is destructure it and pull off counts and result. So what this does is now inside of our function, we have access to counts and result. And then the thing that we return is just a new object that contains counts and result. Cool. But then the one thing that we're not doing here is actually pushing result in. So we would say result.push current number. And that should do it. So this looks weird, but ultimately what's happening is we have this reducer. Not reducer, we have this accumulator. This is the thing that we're operating on and like putting things into. And then each time this function gets called, we get access to those two things. We get access to this object and to this array. And I'm using destructuring to pluck them out. And then we do our same logic. So counts is getting built up and we have access to it. So we do our check there. We add it to counts. We push into result if we need to. And then we just return an object that contains those two things. If this didn't happen, then we're just going to get the object returned, and it'll try again on the next number. And this has done it. Cool. Alka is saying call it like out or ACC, or call it state. I don't know. Yeah, so Dan says destructuring for the win. It really is like, instead of having to think up variable names or like parameter names for your function, if you're destructuring, then you can just use the existing property names from the object, which I do all the time. Like I've been writing a lot of React lately, and I destructure like crazy, mainly because my linter sometimes mostly requires it. Okay, I'm gonna try to turn this into a one-line solution, and then we'll take a look at what the people have submitted in the chat. So here's what we're gonna do. Yeah, I don't know if I can destructure it and return it all in one go. Okay. Here's what I need to do. If I'll keep the parentheses. If this is true, then I need to set... Is this going to work? I need to do this. This may not work. I want to one-line this. Yeah, let's call this state. That was a suggestion from Dan. And then ultimately, this would now become state.counts, 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 state.result. And ultimately, we're going to return state. So this should still behave the same way, but now we're just using the accumulator variable instead of destructuring it. Yeah. I see the chat moving. I feel like people are like yelling at me, telling me what to do on how to make this a one-liner. So I think we'll do, if either of these things, then we're going to do this. Sorry, is that a question mark? Then we're going to do this. We're going to do this. And we're going to return state. Otherwise, we're going to return state. Does this work? Ultimately, what's happening is if this is true, I need to do two things and return state. Let's go back to what I had. Okay, I'm going to take a look at what actually, okay, Alka has a hint here. So use short circuiting and parentheses like in my solution. So short circuiting would be so if it's not in there, or yeah, I still don't see it because ultimately I don't know how these two lines are going to get turned into one line. I am going to look at what Alka submitted. I think Dan submitted a solution too. Oh, and Rabbitworks just broke 1,000 views for their channel. Congrats. Congrats. Okay. I'm laughing because I'm looking at Alka's solution. Okay, so this is what Alka has submitted to us. Wow. Okay, and let's, I think Dan submitted something too. Let's take a look. So this is the solution that Dan submitted. Yeah, so they did a similar thing. So we have, So we have state, which contains counts and array. If the item is not there, set it equal to 0. Increment it. If the counts is less than or equal to the limit, put it in the array. Cool. It's a little bit different than what I did. And then this one is Alka. Yeah, so the one thing that Dan is doing different here is if it doesn't exist, setting it to 0 first, then incrementing it, and then checking if it's at the limit. Whereas I'm checking to see if it doesn't exist and it's at the limit, then I'm doing my work. Okay, let's try and decipher what Alka has done here. So I'm going to put this on a new line. Oh, and he's using arrays instead of properties. That could be why it works. Yeah, so notice his accumulator. Let's do this. We're going to make Alka's solution more readable. Okay. So P, let's call this our state variable. This is the thing that contains the counts and the result array. But you'll notice instead of using an object with properties, he's using an array that contains two things in it. The first element in the array is an object. The second element in an array is an array. So it's like this, but basically you just have to index into the array to get access instead of using the properties. So it's a little bit shorter. So we're saying, does the object... oh, no, we're doing an assignment. So we're saying the object at that number is equal to that object at that number, or 0 plus 1. So this one little bit of code right here is equal to like this line of code right here. Those two are doing exactly the same thing. But yeah, then he's taking advantage of the fact that you can separate things by commas, and then the last thing that is in the comma separated thing will be what is returned. So we're basically taking those two statements. We're saying put it in there, then do our check, and if it okay, I think I see where we could have turned this into two statements instead of three, because this says if the count at that number is less than the limit, push it in. So basically, if this resolves to true, then this evaluates. If this resolves to false, this will not evaluate. And then it returns state, because that's returning your accumulator variable. Whew, that was tricky, but nice job, Alka. Let's put it back on one line. Cool. All right, let's catch up on the chat. Yeah, everybody's talking about plus plus or yeah. Oh, Alka mentions, I would really like to use motion graphics to explain programming. That'd be awesome. Yeah, and Alka actually does have a Twitch channel, so check him out. I think he's just Alka, maybe Alka TV on Twitch. But yeah, check him out. Apparently there was like some thing in the background that was like a space helmet or something. I don't know. Cool. Okay. I'm going to submit my solution on Code Wars. Let's submit this one. Sample tests. Good to go. We'll do an attempt. Submit final. We only got 2 points for that? Or did we get 10? I think this was just updating my previous score. Oh well. Let's see how other people solved it. So I did it this way at one point. Basically, you have they're calling it the cache, but it's the counts. And then they're just filtering and making sure that the counts in there are less than the limit. Cool. That's one thing that I didn't do is like I was always checking before I put it in there, but the thing is it wouldn't have hurt to increment the count, but just not include that result or that number in the array. Cool. This is doing some bit shifting or something. I don't know. Okay, enough of that. I can't believe I only got 2 points for that. Oh well. Okay, this next one is vector class. It's going to be fun. So let's bring it down locally. Oh, Alka is saying tilde is floor. It's not bit shifting. I've never used that before. That's crazy. Okay. And we got some basic tests. So we'll create a vector A. We'll create a vector B. And we're just going to log A add B. And we should get back new vector of 4 and 6. Okay. And actually, I'm going to use class syntax here. So I'm going to create a class vector. We have a constructor that takes in, what did it call it? Components, which is an array. And then we'll do something with it. Okay, let's start up Quokka. A.add is not a function. We will fix that. Okay, but let's just look at the problem description right quick. So create a vector object that supports addition, subtraction, dot products and norms. So for example, oh wow, I didn't see this before, but the components can be of any length. Okay, we'll have to account for that. But you say new vector, you pass in the components, which is an array of all the components of the vector. And then you need to be able to say a.add, pass in another vector, and then get back a new vector that is the addition of those two vectors. I'm curious, vector math should only work on things that have the same length, right? So if you try to add, subtract, or dot two vectors with different lengths, you must throw an error, right? So if we tried to do B adding C, these are two different lengths, so it would throw an error. Okay. Cool. So let's just start with add. So if you've never seen a JavaScript class before, this is one. And you'll notice here that we create an instance of the class, and then we try to say a.add. So, and the error we're getting right now is a.add is not a function. To put a function on the vector class, I'll show you how to do that after this quick break. Oh, Alka is saying the tilde is not, so it'd be not. Interesting. Wow. Yeah, I've never used that before. Okay, but we want to add this method add to the class, and we can just do this. So we'll say add, and this takes in some other vector, and then we'd want to do something with it. But right now it returns undefined. So ultimately what we need to do is this class needs to know about and keep track of its own components. So that way when we're adding it to another vector, we can access all the elements of it with the components of the other one. So what I'm going to do, I think, is just put components as a property on this class, an instance property. So I'll say this.components equals components. And one thing I would probably want to do is I would want to be able to check the length of a vector. Let's see. Yeah, so this is using node 8. I think I can use a computed property. So on this vector, I'm going to create a class called, or not a class, create a computed property called length. And this should just return this.components.length, like that. So that way, from the outside world, I could say vector.length and get the number of components in the vector. But that comes in handy here because I could say if vector.length does not equal this.length, we're going to throw an error. What should the error be? It doesn't say. We'll say vectors must be the same length. Like that. Cool. So that's great. But now we actually want to do the addition. So vector addition is super simple. You just take the two vectors and add each of the components. So we need to write the math to do that. So we'll say, I guess technically we could do a map. Yeah, let's do a map. So the components of the new vector are going to be vector, we'll say this dot components dot map, and this is going to give us a component of the vector, and we'll also get access to the index in the array, and we want to return that component times the vector, or not times, added onto the vector that we passed in, its components at that given indice. That gives us a new array of components, and then we want to return a new vector that contains the components. And we've done it. Okay, I'm just going to pause, and people that are watching can ask questions because there's a lot of weird stuff going on here. So ask away. I feel like people are talking about the tilde thing a bunch. Wow. Whoa. Yeah, it's super weird. Okay, nobody's asking about classes because they're worried about tildes, but yeah. And Alka has written his own vector class, so ask him the questions. I don't know. But basically what's happening here is we're creating this object that has various properties on it that you can use. So in this case, we created an instance of a vector called A. We passed in our components here. That got set on the instance. And same thing with B. And then when we say a.add, inside of here, this is equal to that specific instance of A. So when I say this.components, it's the array of components that got passed in earlier so that I can access it. So when I do this.components and we're inside of A, I'm actually accessing this array. And then we're mapping over it to get each individual component. And then as we do that, we're grabbing the corresponding component in the other vector. So the vector is what gets passed in here. And we know that B is a vector, so we have access. We know that we would have access to its components property. And then we get that specific component. And then it wanted us to return a new vector with those components inside of it. So that's just what we've done. We created a new vector and passed in the components that got created. Cool. Okay, so we've got add. We also want to do subtract, and it works very similar to add. So I'm actually just going to copy and paste this code. Subtract. But now instead of adding, we're just going to do a subtraction right there. Maybe we could refactor this in some way. We could like pass the function that needs to happen. I don't know. This is probably about the same amount of code. So if we, let's look at their examples here. Let's log these. And this should return a new vector of 4, 6, and 8. Same thing with subtraction. -2, -2, -2. -2. Cool. Yeah, and so Alka is suggesting a potential refactor, this.map components. We do need to return a new vector at the end of the both of these functions, but map components could just return an array, and then we use that here. Yeah. Okay, and then we haven't implemented .norm or arc. But so when we do our addition, we're getting back the right result, and when we do our subtraction, we're getting back the right result. So yeah, let's see if we can refactor this. Ultimately, the things that are the same in both of these is everything. The only thing that's different is the actual function that we pass in. So let's say if I were to, I could do a refactor inside of VS Code. Let's do refactor extract to method in class. We're going to call this map components. Cool. But actually the one thing that I do want to pass in is this function. We'll pass in func. Because in the case of that, I want to pass in adding. And in the case of subtracting, I basically want to do the same thing, but pass in subtraction instead of addition. So this will be subtraction. Actually, let's just store it in a variable so it's a little bit easier to read. There we go. Cool. So we've extracted this function so that way we can reuse it for both addition and subtraction. Yeah, I'm guessing. Yeah, then we need to do dot product and normalizing. Cool. So dot product, we could pretty much reuse it, but then we'll need to reduce it as well. So that actually should be pretty easy. But let's just log out what it should be. So if we log out the dot product, we should get 26 as the answer. But ultimately, it's these two vectors. So it's 1 times 3 plus 2 times 4 plus 3 times 5. So what we can do is we can map it to get the multiplication of each and then reduce it to get the sum. So we'll create a new method called dot. Dot. Our function, the only difference is it's using multiplication instead. We then have our components. And then instead of returning a new vector with those components, we just need to reduce it to a sum. Let's take a quick stretch. And catch up on the chat real quick. Whoa. Gaming but not really is dropping some math bombs. Basically, instead of doing like the map that I'm doing, there's a formula for calculating subtraction. Or never mind. Wait. Okay. I think he's rescinded it. Okay. So for the dot product, we have that, but now instead of returning a new vector, we need to just sum all the values in the vector. So I'm just going to do a quick little reduce. And that should do it. Yeah, so we get back 26. So what this did was create an array that included the multiplication of each of the components and then sum them all together. And we have the same error handling logic here. Like if the two things that you're trying to get the dot product of aren't the same length, it's going to throw an error. So I think that's a good bit of like reusable code, I guess. Pranjal is asking, are you doing machine learning? I'm not. So I'm just solving a code wars problem that has us implement our own vector class. But when you're doing that kind of stuff, you probably use vectors and do all sorts of math with vectors. But I'm just doing like super basic. We have a vector class that has components. You can add 2 vectors, subtract 2 vectors, get the dot product of 2 vectors. And now the last thing we need to do is do the norm of it all. Interesting. Okay, so the way this works is you take this to the power of... Wait, no. Okay, how does this work? Oh, no, it's not with another... It's on itself. So a.norm takes each of its items, components, squares it, sums it, and then takes the square root. Okay, I think we can do that. So if we log a.norm, we should get back math.square root of 14. And this one should throw an error. But I think it kills Quack if it throws an error, so we'll leave that off. But okay, so now we need a norm function. Doesn't take in any parameters because it's going to operate on itself. Ultimately, we need to map it. So we could probably do this all in one reduce. So we could return math.square root of this.components.reduce. We're going to get the sum, and we're going to get each component. And we want to return, actually we'll start the sum off at 0. But we want to return sum plus component squared. And take the square root of the whole thing. And we've done it. It's too easy. And if you haven't seen this before, this is the exponentiation operator. It's a bit newer in JavaScript. It's been around for maybe a little over a year or so. But this actually lets you raise something to the power. It's the same thing as math.pow. Alka is saying, I don't remember what the kata was asking for. It literally just wanted us to implement a vector class with all of these methods. So it said implement a vector class that includes add, subtract, dot, norm, and add. Oh, and so the last thing is we need a toString method that should return a string with everything surrounded by parentheses. Okay, so that's our last thing that we'll need to do. toString. And this is just going to be this.components joined on a comma, wrapped in parentheses. So let's do a template literal with parens and then that. And so if we log a.toString, we get that, which is what we want. And we also need an equals method to check that two vectors have the same components are equal. Cool. So that's another method we have to implement. Pass in a vector. And really, we want to return this.components.every. And we're going to get access to the component and the index. And we want to make sure that component is equal to vector.components at I. So this is just an array function that if this returns true in every instance, the whole thing will return true. So this will make sure that both arrays contain the same elements. Cool. We've done a lot. Let's plug it in and see what we're missing, because they don't provide a lot of tests. Sample tests. Works. All right, we're going to do an attempt. Hey, it worked. Cool. So we've got equality, strings, norms, dot product. Yay! Oh, people are mentioning I don't actually need join. Probably because the toString of an array by default separates it on commas. So yeah, that still works. Awesome. And then Alka is mentioning that when I was doing the raise to the power of a minute ago, it might actually just be faster to multiply it by itself. Norm still works, yeah. Cool. catch up on the chat. Hello, Ryan. Ryan asks, have I listened to any good music lately? I was listening to a lot of punk rock, like, just this past week. I was just into punk rock. I used to listen to punk rock all the time. Listen to a lot of, like, NoFX and Rancid and stuff like that. It's old music. They don't have any, like, newer music out. I don't normally listen to that kind of stuff, like, when I'm programming. I listen to, like, Taiko and stuff like that, but I don't know. Lately, I actually haven't been listening to a lot of music. I'll just say that. And hello, Alex. Alex says, Emily says, hey. Hello, Emily. Thanks for tuning in. Cool. Yeah, I think we've done it. Let's attempt it. Submit final. We did it! That was fun. So, I don't do a lot of, like, class-based programming, and it was fun. Cool. Let's see how other people did it. Yeah, so I used class syntax, which was introduced in ES6, but you can see here they're just using functions and prototypes. Ultimately, it works exactly the same way, but it's just different syntax for doing it. Yeah, and we can see they kind of just repeated the logic, so like check for length and throw an error, whereas we kind of extracted that out into like this reusable function, and then we just define what our map function is that we're going to be using. Yeah. Yeah, Bob is mentioning NoFX is melodic hardcore. Yeah, if you actually ever see like interviews with Fat Mike, the singer for NoFX, he talks about how like when the band was coming up, there was like a hardcore scene, but like everybody always considered NoFX punk, but they're more of like melodic hardcore, really because of how fast they play. Like they play extremely fast, so fast. Okay, so that's cool. Interesting. So this person used the prototype, but just made it an object with properties on it, which is essentially the same thing. And they had their map function. They just called it do, and they're instead of passing in a function though, they're just passing in a string of what operation needs to be performed, and they use eval. So you may not have seen eval before, but it evaluates a string and gives you the result. I didn't want to do this because, I mean, in this case, there's no harm in doing it. But you could run into a situation where somebody passes something evil as a string that isn't what you were expecting, and then you end up evaluating it and running malicious code. But yeah. Cool. Okay, that was fun. The last one of the night, we have Tic-tac-toe checker. This one's going to be fun. Alex asks, how long did it take to get to your kata level? I guess probably about a year, because I've been doing, pretty much before I started doing the Code Kata show, I didn't do them as often. Like, I was teaching, and I would have my students do them, but I would only do them every now and then. And so when I started back in January, I was probably pretty low. We could probably go back and look at, actually, let's do it. Let's go to like the very first Code Kata video and see what my score is. We're going way back to like 11 months ago. Number 1. Yeah, so 11 months ago, my score was 77. Whoa. 1080p, full screen. Yeah, so this was about 11 months ago, and I was a 77. And that's doing probably between 4 and 5 katas once a week for like 11 months straight. This is the 22nd episode of Code Katas, so I imagine if you did like at least one a day, you could probably get there faster, but I pretty much only do katas when I'm doing this show. Yeah. Alka is at 382. Yeah, and actually, if you set your clan to be Coding Garden, you'll show up on here. We can see Stellar Tux has a higher score than I do. There's Mia Amsumi, who is in the chat quite often. They're at 656. There's Chad. Chad was watching earlier. Hello, Chad. But yeah, if you in your profile, if you set your clan to Coding Garden, you'll show up as my ally. Cool. All right, last one of the night, tic-tac-toe checker. This will be fun, and then maybe sometime soon I'll implement tic-tac-toe on stream. I don't know if I've done that, and I've wanted to. Do-do-do-do. Do-do-do-do. Okay. Gaming But Not Really is asking how to set the clan. Let's see. If you go to your profile, and I'm sure there's some way to edit your profile, and then you can set the clan. Account settings? Yes, go to account settings and then put your clan there. And it's coding space garden with a capital C and a capital G. Okay, so for this last one, we're essentially implementing a function that receives a tic-tac-toe board and returns true if it is, if someone wins. Well, not returns true. It returns the value of whoever won, -1 if it's not finished, or 0 if it's a draw. So you're going to get a board, which is an array of arrays. So it's an array that contains 3 arrays, and each of these represents like a row in the game board. A 0 means it's empty, meaning no one has played there yet. A 1 means it's an X, and 2 means it's an O. So if we look at this game board, it's like seeing X, X, O, X, X, O, nothing. So no one has won this game yet, but if X were to go first, they could go here, and then that would be a win because they have a vertical win. Okay, so our function will return -1 if the board is not yet finished, meaning there are any empty spots. 1 if X has won. 2 if 0 has won, and 0 if it's a cats game, which I've never heard of, but that just means it's a draw. You may assume that the board passed in is valid in the context of the game of tic-tac-toe. Okay, so in this example, this should return -1 because nobody has won just yet. Okay. How are we going to do this? I don't know. Let's write some pseudocode. So I think we could check it. We can check rows. So did... is X the winner of the first row, or is O the winner of the first row? Same thing with the second, same thing with the third. Then we'll do vertical, and then we can do the 2 diagonals. And if no one is a winner of any of those, then if there were any 0s, then that means somebody could still play, which means it's not yet over. But if it's a full board and nobody has won, then we return it's a draw. Okay. Cool. And Rabbitworks is hanging out. Thanks for tuning in. Oh yeah, I got your DM, but actually I couldn't, if you're still watching Rabbitworks, I couldn't find you in the Discord. So send a message send a message in live chat so I can find your account, because I think your account name on here is different than your actual account name, but yeah. Please do that. Oh, Alka's got a 500 server error on Code Wars? What? Oh no. I'm not going to refresh the page. I'm going to leave what I have open. Yeah, and Alex asks how many years to be able to solve 4Q easily? Several, because I guess I've been programming like close to like 9 years. I can do 4Qs, but a 4Q probably takes me like at least an hour, sometimes more. Yeah. Okay. Yeah, and so someone mentioned a possible solution for this would be to find the sum of the three values. Here, here, and here. And if the sum is 3, that's a win for team 1. No, it's not, because you could have a 2 and a 1. I don't know. Let's write out my pseudocode. So check if each row is solved by X or O. Check if each column is solved by X or O. Check if either diagonal is solved by X or O. And if none of those things are true, then nobody has won. If none of the above true and there are zeros anywhere, not solved, else it's a draw, meaning the board is completely filled but nobody has won. Okay. And hello, Emiliano. Welcome to the stream from Argentina. That's awesome. Okay. Yeah, I think so. I think this is maybe 2 code katas ago, or maybe I don't know if it was last code kata, but I wrote a Sudoku, not a solver, but a function that would check to see if a Sudoku board is solved. This is somewhat similar. We're basically going to have some functions that look at rows or look at columns. Cool. And we'll see you later, gaming but not really. Thanks for tuning in. Yeah, but I want a function that's like is winner, and that will take in a player value, so like 1 or 2, and that will also take in a row, and we'll say if row dot every value in the row is equal to the player's value, then yes, that player is a winner of that row. And really, this is reusable for row, column, diagonal. We just would need to massage it into an array. So let's just say, what do we call this? Like a set. Has various cells. Yeah, so you pass in a player. So for example, so check if each row is solved by X or O. So if we do let's just do, for now, we'll just do a simple for loop that goes from board.length. So we're going to go this direction, and we have each row. We'll say if is winner X's, which is the value 1, and that given row, then we're going to return 1, I think, because player 1 won. Yes. Else, if is winner with 2 in that row, we'll return 2. Cool. So this is going to check every single row to see if either 1 is a winner or 2 is a winner. Great. Now we can do the same thing with columns. It's going to be a little bit trickier. Yeah, here we'll do this. We'll just iterate from 0 to 3. I mean, and really, we're doing the same thing here. We're just going from 0 to 3 because the board is always going to have the same length. But in this case, to get the row, it's not just that given row. It's board at 0 at I. So we need to create an array. We'll call this column. So this is board at 0 at I, board at 1 at I, and board at 2 at I. So board 0, 0 is here, board 1, 0 is here, and board 2, 0 is here. So this will create an array of those 3 values, and that gives us the column. And we're doing that for each column. Cool. And that should return a winner. And then now we need to check the diagonal. So we could probably just hard code it. So we'll say the first diagonal. What's the difference between this diagonal and this diagonal? Cool. Let's call it first diagonal. That's going to be an array with board at 0, 0, board at 1, 1, and board at 2, 2. Forward and background. / forward diagonal, back diagonal. Okay, yeah. So this would be the back diagonal, like a backslash. And the forward diagonal is going to be, we'll go in this direction, 2, 0, 1, 1, and 0, 2. Cool. So really, we got to do this logic. And I'm going to write all of this out and then try to figure out a way to make it shorter and smaller and potentially use like every sum. Maybe we use like a reduce or something like that. Okay. And then if we've made it to this point, then no one is a winner. This is a lot of code. Because we've checked winners in every possible direction. So if none of the above are true and there are zeros anywhere, we are not solved. So if board.sum row and row.sum cell is equal to 0. So what this will do is this will look at every row and every value and see if any one of them is a 0. So essentially the first 0 it finds, it immediately returns true. So if some value in the board and of that some value in the row is 0, return true. So if this is true, then we return -1 because it's not yet finished. Otherwise, we return 0. Okay. What is happening? Oh, I just wanted to see, yes, does this return -1? And it does. So right now, this returns -1 because it's not yet solved. But if we were to put a 1 there, it returns a 1 because 1 is a winner. If we were to put a 2 there and a 2 there, then it gets a 2 because 2 is a winner. If we make a board where no one is a winner, oh, like that, we get 0. Cool. I think we've done it. Yeah, and Bob was mentioning backslash, forward slash, so I did back diagonal, forward diagonal. Cool. So this works. Let's plug it into Code Wars, and if it does work, we'll do some massaging and refactoring to make it look a little bit nicer. So that one's good. We'll do an attempt. Cool. 700 milliseconds. That's great. Let's make this better. Okay. Check if each row is solved by X or O. Can we do this without a for loop? Like, could we use a... Actually, I mean, I like the for loop because we can return out of it, and that basically exits the function immediately. Okay. Okay. And honestly, I've been streaming for an hour and 45 minutes, so I just might leave the code like this because it's working. But there's definitely a way to write this cleaner. Let's see. Yeah, I mean, instead of hard coding each column, I technically could write like another loop that dynamically creates the column, but honestly, it's not so bad to just hard code because you know the board is always going to have a specific size. Alka is mentioning using find. So could we do row.find instead of sum? Is that what you mean? I think those would behave in a similar way. For the first one, we could use find. Yeah. And Joe just asked, can you please submit this code before leaving on GitHub? Yes. Yeah. So I always push up to GitHub. I'll try to remember to do it like immediately after the episode is over, so you can definitely take a look at this code. Interesting. You know, the thing is, I've written a tic-tac-toe solver or checker before, and I think it was just this verbose. I didn't exactly come up with a way to make it any better. The only thing is, you have to think about like how performant is this? Like let's think of some other algorithms. Like if would it make sense to check and see if there are zeros first before checking to see if there are winners? Justin is saying, join all the cells into a string and compare against a regular expression. Interesting. Can we come up with a regular expression that that matches a solved tic-tac-toe board? Because the tricky thing is we need specific groups of X's and O's. So if you think about it like empty space X, empty space X. So this is, let's say this is like the first row, and then second row is O, X. O. And then the last row is O, X, O. You could run into like a tricky case where you're looking at these three elements and they match, but technically that's not a win because that would be like the edges. Ross is suggesting you could create an array of all possible sets and then loop them and check each one with the same if-else logic. So we could create an array of all possible wins. Like 1, 1, 1 is a win for a row. Is that what you mean? Create an array of all possible sets. Please expand. I'm not following. Oh, I see. So instead of doing multiple loops, we create one array that contains all possible combinations. So one array that contains all the rows, all the columns, and all the diagonals, and then loop over that. I kind of like that. Yeah, let's write that as a separate solution real quick. So let's call this sets, and it's just going to be an array of all of the sets in the board, and we'll do sets.push board at I. So let's do this. Let's call this. Let's keep calling it bro. And then we'll push the column. And then we'll push the diagonals. Cool. And then we can just do one iteration over the sets that checks for winners. I think the one reason I like this one better is potentially like if we find a winner here, then we don't go through all the trouble of creating the rest of the sets. At the same time, the sets are so small that it probably doesn't matter anyways. So let's do sets dot I guess we could, I don't really just do a for loop and say if, so set is going to be sets at I, if is winner with player 1 and the set, return 1, or if it's 2, return 2. So that cleans the logic up a bit because we don't have all these if-elses, and now we just have one case of ifs here. Ross is mentioning we could do columns and rows in the same loop. Why, yes, we could. I like that. It is less code. Because basically we get every row, every column, Then we get both diagonals. Yeah, let's throw this on Code Wars, make sure it still works, but it is also a viable solution. Oh no, I think I quit Chrome again. So that still works. That still works, cool. My score has gone down. It's possible that like Code Wars database went down or something like that and we actually like lost points. Alka has a suggestion. Do a study of 1,000 tic-tac-toe games and find the most likely cases and have those run first. That's definitely a way to optimize it. So like, where in the board do people most likely win? Is it diagonals? Like, should we check diagonals first? Is it acrosses? Actually, I think I would bet that diagonals are more a winner than anything else. So I'm gonna move these checks up to the top. Not that it changes anything. It's still going to work in the same way, but the point is, like, if we wanted to get the fastest possible solution, we would check the thing on the board that is most likely to occur. Cool. I think I'm going to end it there. That was super fun. Justin did mention there's a regular expression for solving tic-tac-toe. Let's check it out. Oh, interesting. That's intense. So I would probably never come up with this regex myself, but let's take a look at it. So a person on Reddit asks, is there a way to use regular expressions to see if a tic-tac-toe board is solved? This matches the first diagonal, because I guess it's 1 in the center. I think they're missing a number. But ultimately, this person came up with this regular expression to see if they won. Cool. All right, I'm going to submit this final solution. Yay! Oh, they used a regular expression. Okay. Check for 2s. 2 is a winner. Weird. Check for 1s, then 1 is a winner. If anything on the board is a 0, it's undone. Otherwise, it's a draw. Wow. Check horizontal. Check vertical. Check diagonal, check for game over. Super interesting. Okay. Oh, actually, okay, my score did go up. That's a good thing. All right, I think I'm going to end it there. That was super fun. I am going to push this stuff up to GitHub. Sparkles. Add 12. Today is the 12th. Go. Yeah, Ross is mentioning, so someone mentions someone were to create a tic-tac-toe game that's like a 10,000 by 10,000 board instead of a 3x3, then you can start worrying about performance. But for our cases, the board is so simple. Wow. Alka has a comment for checking powers? Crazy. Cool. Yeah. That's it for that. That was super fun. Thanks for tuning in. Thanks for your suggestions and hints and help. Yeah. I don't know when the next stream is going to be. There may be a noob quest coming up soon with Tony. I've been talking with him. Might be either this weekend or next weekend, but stay tuned for that. There'll be random streams happening. I think I do potentially want to do a stream where... So... If you've been following the Discord, we have this channel called Community App, and we're going to be building a Coding Garden mobile app that has just like news, announcements, and videos, and we'll think of other things that a mobile app should have that is for Coding Garden, and we're going to build it together. So In the coming days, I'll probably be meeting with everyone that was interested, and we'll just be talking about how are we going to run it. And I may even stream those meetings, or like the brainstorming sessions, so you, the community, can help come up with ideas for things that should be in the app, or stuff like that. Okay, that is all I have for you. Thank you, everyone, for tuning in. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Until next time, here's this.